guys, I'm just switching cameras. Okay, so today we are covering 112 properties of real numbers. So we're going to talk about several different properties and what they look like. Okay, so the commutative property, I see it as commute. The main idea for this one is order does not matter with addition and multiplication. This only works with addition and multiplication. The commutative property only works with addition and multiplication. Okay, so let's look at a couple of examples. We would have A plus B equals B plus A. This is addition examples. Notice just the order that it's written in is changed. 7 plus 5 is the same as 5 plus 7 because both end up with 12 as the answer. It doesn't matter which order we write it in. 3x plus 8 is the same as 8 plus 3x. Y plus 9x is the same as 9x plus y. Notice the signs are the exact same. It's just the order that it's written in. Okay, multiplication. A times B is the same as B times A. We have AB times 7. That's the same as 7 times AB. Another example here could be 2 times 3 is the same as 3 times 2. Notice they both end up with an answer of 6. I have negative 5y times 4. That's the same as 4 times negative 5y. Notice my multiplication is being shown by parentheses. If we have in parentheses x plus y close parentheses with the 3 on the back, that is the same as 3 open parentheses x plus y close parentheses. It is the same thing whether we're multiplying it to the back of it, the parentheses, or the front of the parentheses. That takes care of the commutative property. I think about the commutative as the commute, like your commute back and forth to school. You may take a different path, but you still get to your home to school. You don't have to take the same path every time, but you still get to the same place. Okay, associative. Association, that's a group. Okay. Association symbolizes a group. So our main idea is grouping. Does not matter with addition and multiplication. Again, it's only addition and multiplication. So with this, change what's inside grouping symbols. Change what's inside the grouping symbols. For up here, I'm going to kind of write a little note here. Change order. When you do the commutative, you're changing the order. Change order. For commutative, associative, you change what's inside the grouping symbols. All right, so let's look at some examples here. If we have 8 plus 9 plus 7, that's the exact same as 8 plus 9 plus 7. Notice what's inside my parentheses is what changed. So that's the commutative, the associative property. What's inside the parentheses changed. Not the order that they were written in. It's still 8, 9, 7, 8, 9, 7. It's just what's inside the parentheses changed. Another example is x plus y, close parentheses. So in the parentheses is x plus y plus z equals x plus, open parentheses, y plus z, close parentheses. Those the letters are still in the same order, just what's inside the parentheses is changed. Next example, 7a plus, open parentheses, 2 plus y, close parentheses, equals, open parentheses, 7a plus 2, close parentheses, plus y. It's just changed where the parentheses are located. Last example for addition, 6 plus, open parentheses, 3a plus 1, close parentheses, equals, open parentheses, 6 plus 3a, close parentheses, plus 1. Now let's look at it for multiplication. We have a, open parentheses, b times c, close parentheses, equals, open parentheses, a times b, close parentheses, c. Notice that what's inside the parentheses is changed. The order is still A, B, C, A, B, C. Next, 7, open parentheses, 2 times 1. It's all multiplication that's occurring, equals, open parentheses, 7 times 2, close parentheses, 1, because it's all multiplication that's happening. 6x times 2y times 3, 6x, open parentheses, 2y times 3, close parentheses, equals, open parentheses, 6x times 2y, close parentheses, 3. Last example here, 4a, open parentheses, 3b times 5c, close parentheses, equals, it's the same as open parentheses, 4a times 3b, close parentheses, times 5c. Those are all the same thing. You're changing the grouping symbols. What is inside the grouping symbols? All right, next, identity. For identity, that's making it, talking about yourself. So the main idea is keep the value of the number. It's equal to itself. So for instance, for addition, pretty much means adding 0. Add 0. So I'm going to have 9 plus 0 equals 9. It's equal to itself. X plus 0 equals x. Equal to itself. 4a plus 0 equals 4a. Negative 7g plus 0 equals negative 7g. Notice throughout all of these, we're adding 0. Added 0, and we added 0 for all of these. Now we're looking at multiplication. That's when we're going to multiply times 1. So I'm going to have 7 times 7 times 1 equals 7. Notice it's equal to itself. 1/4 times 1 equals 1/4. It's equal to itself. 6x times 1 equals 6x. Negative 3b times 1 equals negative 3b. And notice we're multiplying by itself. Or sorry, you multiply times 1 and you get itself. Moving right along. The inverse property. Inverse property, when I think of inverse, I think of opposite. Okay? So the main idea is use the opposite to cancel out. So for addition, examples would be 10 plus negative 10. They cancel each other out and it equals 0. So for addition, it's going to equal 0. Anytime that you have it equal to 0 and you have the opposites, that's the inverse property. So in other words, if I have 1/2 plus negative 1/2, positive and the negative added together cancel each other out and it equals 0. Negative 7 plus 7, so negative and a positive, add them together and you get right back to 0. X plus negative x, one's positive, one's negative, so they cancel each other out and it makes a 0 pair. It equals 0. So again, if they're opposites and it equals 0, it's the inverse property. For multiplication, this is where it's going to equal 1. So I'm going to have 10 times, the inverse here for multiplication, okay? A lot of times it's the flipped fraction. So I'm going to do 10 times 1/10. 10 times 1/10, because if I'm working that, then I put the 10/1, and it becomes 10/10, which is 1. So if we've got another example here, if I have negative 1/3 times 3, they're the reciprocals of one another, this equals 1. X times 1/x. That equals 1. 5/4 times, this should be in parentheses, times 4/5 equals 1. Now remember, to see this, multiply straight across, and we get 20/20, which equals 1. Remember when we multiply the fractions. Okay. Looking at the property of 0. Property of 0. Anything multiplied by 0 equals 0. Anything multiplied by 0 equals 0. So examples for this, if I do 5x times 0, that's going to equal 0. Anything times 0 equals 0. If I do x plus 7y, but I multiply it times 0, it's going to equal 0. It doesn't matter what you multiply by 0, it equals 0. Last one, the distributive property. The main idea, distributive property. So we're distributing what's on the outside to what's everything on the inside. Multiply what on outside to everything inside parentheses. So more mathematical way is multiplying a value to an expression in parentheses. So you multiply what's on the outside to everything on the inside. So I'm going to have 5, open parentheses, x minus 2, close parentheses. Some examples of this. Equals 5x minus 10. So I'm going to have 1/2, open parentheses, 20x minus 4, close parentheses. What I did, by the way, for this top one, I take the 5 and I multiply it to everything inside. So I had 5 times x gave me 5x, 5 times -2. So we had 5 times x minus the 5 times -2. So that's how I ended up with 5x minus 10. So here, if I'm going to do 1/2, half of 20x, that's going to give me 10x. Half of -4, that's going to give me a -2. A couple of more examples. A times b plus c if we have just letters. So I'm going to have a times b, so that's going to give me ab plus a times c, which then gives me ac. And then I'm going to have -7, open parentheses, x minus y, close parentheses, equals -7x plus 7y. Because I'm doing -7 times x, which gives me -7x. -7 times -y, that's a -y times a -7, that gives you a positive 7y. All right, this last section right here, okay, you're going to complete this on your own. So you're going to check below with Mrs. Wilson without looking at the answer key first, okay? Have a great day.